Good evening all. Today we are going to see about the induction type wattmeter. Okay. The induction type wattmeter is used to measure the energy value. Now we are going to see that what is energy. Energy is the product of power and time for which power is used. Energy is equal to power into time. The induction watt-hour meter or energy meter, which are commonly used, measured electrical energy in kilowatt hour. The unit of energy is kilowatt hour. The energy will be measured by using the induction watt-hour meter. Next, we go for the energy meter. An electricity meter or the energy meter is a device that measures the amount of electric energy consumed by a residence, business, or an electrically powered devices. Most common devices to measure the energy is kilowatt hour meter. Measures the instantaneous volts and amperes. Measure the time period electricity is used. Integrates the instantaneous watts against time to give the energy used. Okay. The energy meter is mostly used to measure the voltage and current values. What is the unit of voltage? The unit of voltage is volt and the unit of current is ampere. Okay. Measure the time period the electricity is used. What is power? Power is equal to voltage into current, V into I. Energy means what? Power into time. So the voltage and current value with respect to time, that is called the energy. So the unit of energy is kilowatt hours. Next, the induction type watt hour meter. The electromechanical type energy meter, what we use in our domestic and industrial installation in single phase induction type watt hour meter. Although nowadays the electric supply companies are replacing the conventional electromechanical type meters by a digital one. Nowadays we are using, most of the cases we are using the digital watt meters. But still we need to know the basic function and constructional features of induction type single phase watt hour meter for our knowledge base. This type of energy meter measures the electrical energy in a kilowatt hour. That's why sometimes we call this meter as kilowatt hour meter. Next, we go for the working principle of watt hour meter. Constructionally, an induction type single phase watt hour meter has many similarities to an induction type watt meter. Moreover, the working principle of the watt hour meter is more or less similar to that of an induction type watt meter. We do not provide any control spring and pointer in energy meter. Instead, we provide a braking magnet. This is a constructional diagram for watt hour meter. Here we see that here we are using two magnets. One is the shunt magnet and another one is the series magnet. The coils are wounded in that magnets. Okay, first the shunt magnet is E-shaped magnet and that series magnet is U-shaped magnet. Okay, here we see that the supply voltage is given to this shunt magnet and this load is to be connected between these two magnets, and that aluminum disc is rotated in between these two magnets, and the braking magnet is at the tip of this aluminum disc. This is a arrangement of watt hour meter. An induction type energy meter consists of an aluminum disc on a spindle in between two electromagnets, so the disc is free to rotate. Here we see that this is a aluminum disc. It's to be rotated between these two electromagnets. We connect one electromagnet across the supply main, so it makes the flux of this magnet proportional to the system voltage. We connect one electromagnet across the supply main. Here we see that the one electromagnet is to be applied to the supply voltage. So it makes the flux of this magnet proportional to the system voltage. We give a supply voltage means that magnet produce some flux. Thus that flux is proportional to the system voltage. Hence we call this electromagnet a shunt magnet. The core of this electromagnet has three limbs. In an energy meter, normally the central limb of the shunt magnet holds the voltage coil. The core of this electromagnet has three limbs. The energy meter, normally the central limb of the shunt magnet holds the voltage coil. This is a voltage coil. Next, then we connect another electromagnet in series with the supply line. This is a series magnet. Thus, we call as the electromagnet a series magnet. Unlike the shunt magnet, the series magnet consists of two limbs. Each of the limbs hold the half of the current coil. The series magnet have the current coil. Here we see that the series magnet have two limbs, 1 and 2, and one half of the current coil, and this is a second half of the current coil. Since we connect in series with the supply line, the flux produced by this coil is proportional to the supply current. Another basic component we use in watt-core meter is braking magnet. This is nothing but a U-shaped permanent magnet. The edge of the aluminum disc rotates in between the poles of this permanent magnet. The flux of the magnet produces eddy current in a disc. As a result, this arrangement provides the braking torque to the rotating disc. Then only here we are using the U-shaped magnet. Okay, that is called as a braking magnet. It used to give the braking torque to the rotating disc. Next we go for the induction type energy meter. The electromagnetic induction. What is the electromagnetic induction? The electromagnetic induction is the process of production of voltage across a conductor when it is exposed to a varying magnetic field. That is called a electromagnetic induction. All it needs is just the relative motion between the electromagnetic field and the conductor. Discovered independently by the Michael Faraday and Joseph Henry in 1831. The electromagnetic induction is to be discovered by Michael Faraday and Joseph Henry in 1831. Application of electromagnetic induction. Electrical generators, induction motors, transformers and electrical measurements. These are the applications of electromagnetic induction. Single phase induction type energy meter. Here we see that this is a single phase induction type energy meter diagram. Here we see that one round electromagnet, and this is also have the aluminum disc and the pressure coil. This is also have the pressure coil and current coil. Okay, next these are the four systems inbuilt in this system: driving system, moving system, braking system and registering system. These are the four systems in that energy meter. Next we go for driving system. This is a constructional diagram for this single phase energy meter. Here also having one shunt magnet and the series magnet. The shunt magnet have that pressure coil, and that pressure coil also called as the voltage coil, and that series magnet is called as an series magnet is to be connected series with this supply voltage, and this have this current coil and is to be splitted. Next, driving system consists of two electromagnets, one formed by current coil and another by a voltage coil or pressure coil. It develops torque to rotate the moving system. Shading bands are bounded to make angle between the flux and applied voltage equal to 90 degree. Actually, driving system means it consists of two electromagnets. One is the series magnet, another one is the shunt magnet. And the shunt magnet have this voltage coil, and that series magnet have the current coil. Okay, this is the arrangement for driving system, and it also develops the torque to rotate the moving system. Okay, here we see that this is a shading band. Its shading band is used to make an angle between the flux and applied voltage equal to 90 degree. Next we go for the moving system. Consists of an aluminum disc mounted on the spindle, which is supported by pivot jewel bearing system. Rotation of this disc is based of energy measurement. Braking system consists of a permanent magnet of a C-shaped covering a part of rotating disc to provide the braking torque. This torque is opposite to driving torque. The braking system is to be controlled by that braking magnet. The torque is opposite to the driving torque. Registering system displays the amount of energy. Next we go for the working of the energy meter. When the energy meter is connected in the circuit, the current coil carries the load current and the pressure coil carries the current proportional to the supply voltage. The magnetic field produced by the series magnet is the phase with the line current, and the magnetic field produced by the shunt magnet. It is this quadrature with the applied voltage. Thus, phase difference exists between the fluxes produced by the two coils. This setups rotating field which interacts with the eddy current produced in the disc and produces the driving torque, and the disc starts rotating. Number of revolutions made by the disc depends upon the energy passing through the meter. The spindle is geared to the recording mechanism so that the electrical energy consumed in the circuit is directly registered in kilowatt hour. Working. The speed of the disc is adjusted by adjusting the position of the braking magnet. The braking magnet is used to adjust the speed of the disc. For example, if the energy meter registers less energy than the energy actually consumed in the circuit, then the speed of the disc has to be increased, which is obtained by shifting the magnet nearer to the center of the disc and vice versa. These are the advantages of induction type energy meter. The induction type energy meter have high accuracy, and they have simple and robust in construction. They require minimum maintenance. They are cheap in cost. Their range can be increased by using instrument and transformers. These are the video links I give. We go through and see that videos to graphical working of that. We see that graphical work of that energy meter. Thank you.